Good morning, everybody, or good afternoon if you're out on the East Coast. My name is Holly. I'm with Aesthetic Professionals. We are a distribution center, a lab, and an education center, and we've been putting on some webinars over the last couple of weeks with the help of our partners like Adrian from 3D Systems. And I know everybody's really excited to get into stacking with the Nextdent, so I'll be really quick. We will more than likely have some other webinars coming up, so just keep an eye on our Eventbrite page. And I'll also send out an email after this is over with the link to the webinar. And you also send a link to the Eventbrite page so you can keep an eye on that. Let me see here. Oh, if you have any questions, just put them in the question bar, and as we go along, I'll be able to ask Adrian. And thanks again, Adrian, for doing this for us. We really appreciate it. I'll hand it over to you.
Hi, everyone. My name's Adrian, and thank you for joining me today. I'm going to go over a little bit of review, a little bit of history, and then jump right into stacking and a few new features, how to post-process, what the capabilities are, where your limits are, and how to cram as much into that build as you can. So I'm going to start with a brief PowerPoint, and then I'm going to do some live nesting. I'm going to do live post-processing, show you a couple of upcoming features and a couple of things you may not know that exist in 3D Sprint, and then open it up for questions if you have anything. So by the way, you do get CE credits for this, so if you need those, go ahead and ask Holly. Also, if you're interested in trying out the beta software, it will be released by the end of the month. However, we will open it up to certain people. So please, if you're interested, and please contact Holly and she will connect us. And so with that, I'm going to go ahead and start my presentation. So as you know, printers and accessories, if you're anything like me, I have been working in a large lab for many years. I'm a dental technician, and we've continuously added printers to our fleet, mills to our fleet, all types of manufacturing equipment. As the demand grows and as you need to do more and more different things, you keep adding printers. With every printer comes more accessories. With every accessory comes a new light box and new types of materials and things like that. So then pretty soon things start to go into the storage unit. So the ultimate goal was to have a printer that would meet all of your demands, right? In dental, we have specific things. For example, we need speed without compromising our quality and our accuracy. We needed reliability. If you have any experience in the past of 3D printing, everybody was kind of settling for 70% reliability or 80%, and we were really happy with 90 or 95. But that's not enough anymore. The bar has been raised, and now it's time to not settle for that. And if you have any issues at all, you know how frustrating it is to have a failed print in the middle of the day when you have something that has to go out, which is every day. You come in, you had an overnight build, everything failed in the middle, things like that. It's just not good enough. It's frustrating, even if you only have 1% failure rate. We needed quality resins for every indication, not a printer for every one printer that's good at each thing. We need a printer that's good at everything. And we need it to be consistent. Something that's easy to install and use. So if you have any experience like I have with printers, you've probably seen that it takes almost a day sometimes for people to come in and install your printer. You don't have to do that anymore, thankfully, and you don't have to spend a huge chunk of change as much as you would on your printer to have somebody come in and install it. So these are just a few of the key points. We needed it to be affordable. With the affordable cost of entry, we need to be able to see that ROI early on. And constant innovations. I've purchased a couple of printers where they just stop innovating. There's no new materials that come. There's no new software that comes. You're just stuck with that same thing. And so until you see that ROI and are able to invest in another printer, you're stuck with what you have. So we knew we needed that. And great support and training. Who's been left high and dry, right? So the final point now, and this is where we lead into today's content, is increased capacity without having to add more machines and labor. You shouldn't have to buy a new machine if you need to do more parts. And we notice that people need more capacity. They need to be able to come into a full big build of prints. So as you know, 3D Systems is no stranger to large demand manufacturing. But I wanted to give you a little bit of a history lesson on where Figure 4 was developed and why we are always on this constant road to bringing in more capacity and what the goals set. So this is something from 2011, and this is the granddaddy of your Nextdent printer. I'm just going to turn that sound down. So that's just a preview of what has all gone into that Nextdent 5100 printer. So now they've introduced all of that reliability, speed, capacity into a machine that actually fits in your office, and the same accessories for all of your materials. So now as new materials come out, new processes come out, such as stacking, you don't have to purchase more accessories and everything. So everything that I talked to you today about and show you, you'll be able to use all of these same accessories for that process and for all of the new materials and indications that are coming. So we're not going to go over all of the materials today. We did that yesterday or a couple days ago, but I am going to be doing probably another overview of general capacity and different types of materials that we do offer. Today we're just going to stick with models, but the same types of protocols will come with everything. So let's take a closer look at model 2.0. We have the 3 different shades: gray, peach, and white. And you can do about 20 to 40 minutes, you can do a build. So depending on the height of the model and the type of build that you're going to do, whether it's prosthodontic or orthodontic, you can get about 90 a day out of your machine. And that would be in your 8-hour day. And you're looking at about $1.80 to $3.30 per model. It's the same with your orthodontic models. So doing a vertical build. And then what you come here today for is around 30 models. That's just an average. It is anywhere from 18 to 36, and even 40 I've seen on the builds, and around 120 minutes. And that depends on the height. If you max out your Z height, which is 7.7 inches, you will see that it'll be more or less 2 hours, 2 hours and 5 minutes, something like that. And that's around 120 models a day. And that's just in your 8-hour day, and if you start a build before you go home at night. So how are we able to get that type of accuracy all the way up to 7.7 inches, a full build? How is that even possible, right? How are we able to have these very small supports and very good surface qualities? So I'm just going to give you a couple of basics. If you joined me in the last couple of courses, I usually go over this just to help you understand how we're able to achieve this. So in traditional DLP printing, you can see the build platform, and it's top down, and you can see the projector, and it shines the light onto the build plate. And this is the resin, where the resin is held. Now with the Figure 4 technology that I showed you just that quick video of, and the new Nextdent printer, it's a 5x3 by 7.7 build area. We use a 1920 by 1080 projector, and the reason why we're able to have that 65 micron pixel is because we didn't stretch that projection onto a huge build platform or build area. So we're able to keep that accuracy and that small pixel reliable time and time again. We also have a perforated build platform. So the pressure that comes from not having that perforated build platform against the membrane, and a lot of times it'll be just a piece of glass or some type of film that you're not sure about, and it actually adds to adhesion and heat, and that's why you see all of the very large sprues. So the real key is this resin tray here. So I'm going to show you a couple of examples of what happens when you don't have the figure 4 technology, but what also the benefits are. So it means that you actually can reuse your tray for every single type of resin. You can clean it out. It's made of aluminum, so you can recycle it. It gets around 1,200 builds if you take care of your build platform and your resin tray. I'll show you a couple of tips and tricks on how to do that. And it doesn't expire. You don't have to throw it away constantly. And it doesn't ever fog up, so you don't have to worry about nesting around certain areas to keep the accuracy there and things like that. That accuracy remains through the entire life of the tray. It also has little lines that show you how many grams are in the tray, and I'm going to show you a couple of tips on how to know how much resin to put in. And you don't have to throw them away constantly. If you're anything like me and you had to build a lot of parts, you would just have an auto order of resin trays because you needed them constantly. And if one broke, you had to have it on backup, or it expired, you didn't realize that it was close to expiration. And you don't have to have as much resin in there as you do with some of the other resin trays. It also means that you can have nice thin parts. So you are able to actually have a 1.5 millimeter model wall without warping, which also helps with the stacking process. So we're able to conserve a lot of material by not using solid models for your orthodontic arches. It doesn't warp because it's not pulling off of that film and it's not coming down and touching that film constantly. Every single build, there's actually a zone where it's not touching, and so it's not peeling off of that membrane. And it doesn't have that adhesive force, so you didn't get 3.5 hours into a build or 2.5 hours or whatever it might be today and have it pull off because there wasn't enough resin to flow in or there was too much of an adhesive force. It's more cost effective because you're saving material, and it's also less labor intensive. So I don't know how many people here, which I can't see you, unfortunately, but they've had to go through and chisel away all of their parts. And this is what we did on every build. And you can't do that with a really thin model wall, right? So that's what it's like to take off model prints a lot of times. So if you joined me yesterday for the general session, you would have seen me pull off the models. And it's like that with all of the parts. You can actually just pull them off. So I'll show you a quick video of that. So basically, you'll just twist your model and just rub off your support structure. So you see it just pulls right off, very thin supports, and there's no scarring. So even if it's on a die in a seating area, you'll just rub off those supports and then put your models in your alcohol and punch out the rest of your tray. It also means that you have less support structure, and which means less scarring. So this is normal for a lot of printers, is you just get used to seeing all of the support structure. And then you have to recontour them. You waste all of that material, and this is just typical for what you normally see. But with ours, you see such fine tips that you can just rub them off like you saw me do with the models. And that's from all the lack of adhesive forces and the heat buildup and warping that happens in typical printers. It also affects your surface quality, so you wonder why our models look so smooth and why our parts look so smooth. And I brought this part over on the left, you see the bridge. I printed that on the Nextdent printer out of MFH, and I brought it to a friend, and he put it on this model. And I just couldn't believe the quality of model for the quality of work that he does, and this was the model that he was accepting, and it was just normal to him. And same with this printer surface quality for gingiva mask. It's nothing like what you were used to working on in standard workflows. We need something better, at least better than what we used to use in standard workflows. And same with pump lines, right? So your resin tray affects your surface quality. Now, that also leads me to the Sprint software. So even if you get a beautiful print, consistent prints, how long does it take you to nest? How stable is your nesting software? And what are the perks of that? So with the 3D Sprint, if you already have the printer, you know that you got one license with the printer, a full license. You get free updates, and we do update regularly every time we find a better way to do things, or an improved way, or a new material, or new build style, like the stacking comes out. We'll update that on your Sprint software for free, and it's easy. It just tells you there's an update when you open your software, and there's no annual fees. So all of those free perks are, or all of those perks are free. And there's a whole team that's dedicated to 3D Sprint. So unlike some companies where they're private labeling software that's out there, we actually make this software, and so it goes perfectly hand in hand with the materials we have and the printer. So the hardware, materials, and software all work really well together because of the teams that work together. So what are the benefits of that? And I'm going to show you live the actual benefits of auto placement, auto supports, no previewing slices. You don't actually have to check slices anymore like you used to have to do. You don't have to check for support areas. You hit one button and it puts the supports on there. And the slicing is really fast. There's no calculation time. And I've spent a lot of years of my life, I feel like, checking slices, waiting for calculations, recalculating things. And now I was amazed when I first started using this because I didn't have to do that. And anti-aliasing. You don't have to know what anti-aliasing is, but I would like you to be able to visualize it. So all of this equals less chance of failure. These are just slicing errors that happened with our printers. And I mean, I just snapped these with my phone because I was just so irritated by, after an hour of me waiting to print, there was no indication anything was wrong. And an hour and a half later, I get it and it's missing slices. Same with this one. It took 3 hours for this tray. I pull it out and you can't see through this printer. It's in a canister. So I couldn't see anything, but it appeared to be doing the right thing. And sure enough, it was missing slices. And you can tell because they're straight. And so that means there was a slicing error while the software was calculating it. And obviously, time and frustration is a huge benefit to robust nesting software. So I want to give you a quick example of nesting single level of prosthodontic models, and then we're going to move forward and I will get to stacking quickly. So if you missed any of the sessions that we've done already, this is what it looks like to nest. And I have this also, we have 3D Sprint how-tos as well, and videos on our user guide. And this is just a quick video I made for some customers. So what you'll do first is you'll select your printer, and we will be doing this with the stacking, but this is just for prosthodontics. And you choose your model material, and you choose what type of build. And then you're going to bring in your files, and you can hit Control-I if you like hotkeys, or you can click the buttons up top, bring in all of your models, and then you'll hit Auto Place. And go ahead and change that to 0 so you can cram as much in as you can and allow Z-axis rotation. And if you have even more parts, you can hit 0 on the boundary to the build platform. Now you can look and you see that, and then you'll hit Smart Support and create your supports. Now if you see, it looks like things are very, very close, but actually you can print that close together without having any issues at all. Now, if you want to move things around, you can hold your Q button and grab them and just move them, or you can hit Transform, and you add it to the queue. Now, if you want to see this in more detail, I did a general session, and Holly would be happy to send that out for you. It has how to post-process your prosthodontic models and your implant models as well. And there's a few other things you can do, and you can repair your data. So if you want to scan a model, a patient, and just see the diagnostic, you don't have to go through a model creator, you can just go right in. Or if you were going to mill something, but you wanted to see a prototype and print it quickly, you can actually just use the same method. And as you know, when you go to mill something, it's actually not made to print. But with 3D Sprint, you can skip Mesh Mixer and NetFab and all those extra software. You can come straight into Sprint and fix everything and send it right to the print. And it also even has an export button So if you're using 3Shape and you have a hole in the data and 3Shape's not accepting it, you can just bring it into your sprint and use this technique and then export it back out. So all you'll do is, this is just an intraoral scan. You hit prepare and fix, and you'll hit fix, and it'll close all of the holes or any overlapping data or anything like that that you would generally go in and use Mesh Mixer for. Unless you're an Exocad user and you can just do it there. Okay, and then Smart Support, and you can add it to your queue. So it's a quick way to repair a scan. You can also add labels. So if you are a lab and you want to put your logo on your articulator, or you want to put a patient name, you can use a drawing. And if it's a DXF, which you can easily get online and just make an STL or a JPEG into a DXF, you can use that as your logo. And you can hollow models. Now, there's a couple of ways. The stacking that I'm going to show you actually hollows them automatically, but this is a way to do it if you don't want to use stacking. So you'll hit holes, and you're going to say how thick you want your model walls, and that'll hollow it out. Now, there's a lot of fun things that you can do, advanced functions, with the splitting tool, because there's connectors and things. So you can get really creative if you're a person that likes to play with software. If not, just take off that connector and delete the base. And then there's Boolean, which I need to make a new video for this because it actually doesn't show it as detailed as I'd like. But this one was just an example for, I had a try-in. I wanted to do new tooth setup. I had scanned the patient after the try-in. So I adjusted the occlusion on my Exocad, and now I brought in the arch. It lines up perfectly because it comes out of the same CAD software. And so basically I'm going to select my teeth and select my try-in and hit subtract. And it will cut out that new setup out of my base. And you can get real creative with Boolean too. You can add parts and combine them together. You can use it as a subtractive. And the last topic is anti-aliasing. So I don't need you guys to remember the name of anti-aliasing, but I want you to be able to identify from the surface of something that you're looking at, a printed part, if you're shopping for a printer or if you're inspecting your parts, do you see all the pixels, okay? This is the strength of a software team, an amazing software team. Without distorting or washing out any of the detail, are they able to give you a smooth surface? Okay, and here's another example, a model. Now that denture, you would probably use some pumice and things like that, so it'd just take you an extra minute or two. But when it comes to sending out a diagnostic and the doctor is going to make temps on it, or you're going to present it to the patient, the one on the left is from the Nextdent, and the one on the right is from another printer. And I just want you to look a little bit closer and see all of the little ridges. This is not layer lines. This is actually lines from the pixelation. And so you would have to actually smooth this out before you made your matrix and clean it up, or the doctor would have to clean up the temps. And if you look at this one we were able to just use a handpiece and polish it up. You could also use some floor wax like you would your standard diagnostic wax ups. But this is model white. So let's talk about stacking. Now, all of that, I just wanted you to know how we were able to make it possible and still give you that nice surface quality and maintain our accuracy. So that's the prequel to now stacking. So why would we even do stacking, right? What did we hear from everyone? And why did I personally think it was very necessary in a high production department? Or even if, let's say that you're a doctor and you want to print an aligner series or something. Imagine printing all of those models and coming back and cleaning them constantly and things like that. So what did we hear? We heard that I want more throughput without buying another machine. Big one. I don't have time to clean the build platform every 30 minutes. The printer's too fast. I've actually heard that. The build plate isn't big enough. I need to fit more parts in my build. My technicians spend way too much time nesting, AKA playing Tetris. I want to come in to more prints in the morning. I'd love to save money on resin by making hollow models, but I'm not going to spend the time hollowing them all out. So a lot of orthodontic software actually outputs a solid model, and you have to go back through and re-hollow them all out in the model module. So, so we hear all of these things, plus more. So here's a little intro. 3D Systems is no stranger to maxing out Z-axis. We've been doing it in aerospace, automotive, industrial, all different types of fields. But it's a little bit different when you're working with organic shapes like arches, like models, like dentures, like crowns. So it took a little bit more development. So you've heard us talking about it for a while. It was in development. It's almost ready to release now. We're in the last couple of stages. So now we've got our orthodontic models. And I'm going to show you why and how you can actually save time and material by just using this on a daily work basis. So it has automatic hollowing and placement and support. So you save around 20 minutes if you were going to actually do it manually. You can nest 1 time instead of 4 times. So you save about 15 minutes of nesting time per build. You can start your printer 1 time instead of 4 times. So instead of walking to your printer, stirring your resin, taking off the build platform, starting it again, cleaning your parts 1 time, so instead of going back and forth to your workstation, drying and curing your parts 1 time instead of 4 times, printing 4 levels per build, saving almost a couple hours of time and labor per day. And plus you actually save material, and I'm going to show you how, with less support, less waste, and less residual. Okay, so what we're going to do is I'm going to show you live nesting. Are there any questions about what I've shown you so far?
We are
Holly?
good right now, Adrienne.
Okay. Okay, so here's what we're going to do. The first thing that I'm going to do is I'm going to show you how to use the automated nesting for just a single level of arches. So you guys don't have to do 4 levels. You can do just 1 level if you'd like. So let me show you what you're going to do. First of all, you're going to hit printer. And let's use the tooth maker printer. And we're going to use model material. We're going to use white because so far we've optimized it for white, but peach and gray are really quickly on their way. Okay, and the next thing you're going to see when your update comes out is you're going to see ortho stack, orthodontic, prosthodontic, and you'll see 1 more, which is called the premium build style. This is just a release candidate right now, so we'll hit set. Okay, the next thing that you're going to do is you're going to use Control I, which would be your hotkey, or hit import. And let's do the single level, which I have prepared here. And I'm going to go over, after I show you how all of this works, I'm going to go over what you can look for in your models to know how many you can fit in the build platform, in the build area. Okay, so go ahead and bring those in. Okay, so now you just have a jumble of models. So you're going to hit stack arches and hit apply. And so you can see that they're solid models. Some of them have labeling. And depending on how many programs you have running on your computer and how good the processors are, it could take a few seconds to calculate this. Okay, so you can see what it did was it placed them in the order in which that they could fit on the platform. So you see this arch is really wide. So it actually took these sideways. So we have 7 arches here, and it has lingual supports. And I'm going to show you how easy these break off. So don't be afraid of those. And it has little feet here too. And I'm going to show you this live. But the cool thing about these little feet are if you have a full stack, you can actually put that whole stack into your cure oven standing up. Okay. So what it did was it hollowed them out, put a lattice structure, put the lingual supports for any overhanging areas, and you'll hit add to queue. Okay. It does a double check of your data. You can name your stack. And now it's going to send it over to my queue. Now, depending on your internet speed and things like that, that's how long it could take to pop into your queue. So maybe about 15 seconds, 20 seconds, depending on how large that stack is. Okay, so when it's done doing that slicing, I'm going to show you the full stack. So if you have more than, this is 7 arches. Now, one of the cool things about this also is if you're doing a single level, it's still just around 30 minutes. So I'm going to go back to print. I'm going to do a quick estimate to show you. Okay, so it's about 34 minutes for these 7 arches. Now I'm going to close this file, and I'm going to show you a full stack now. So File, Import, and let's do our full stack. And I'm going to show you what happens if they can't all fit on the plate, or you have more room. So I'm bringing in 28 arches, and they're all different sizes and shapes. Some are a little bit thicker and taller and wider than others. And obviously, you're not always going to have the most ideal because they're all humans. So they have tons of different geometries, and depending on who you have designing your models, this is a lab that uses DLP, and they want their models to be as short as possible. Okay. And this lab, you can see, this is just a sample case here, it's a little bit taller. So what I would say is the more arches you want to fit, just make them as short as you can while still maintaining the geometry that you need to post-process those or manufacture them if you're doing suck downs or night guards or perio cases. So hit stack arches. And you don't need to change all of these different settings. If you just use the settings that we gave you, you're going to have great results. But there are a lot of settings that you can mess around with once you get comfortable. And we also have our best practices, which I encourage everyone to always check out because we're constantly adding tips and tricks and troubleshooting and things like that. And if you ever want to find that best practices, you can just go to the top right of your screen and there will be a question mark. And just hit that anytime you're doing anything, and it'll bring you right to the user guide. So there's a bit more calculation here, and but it is going through every single arch, hollowing them out. It actually is repairing the data as well. A lot of these ortho software these days put out really bad files. You probably already noticed that, but this automatically fixes them, so you don't even have to go into prepare and fix anymore. Okay, so it'll tell you if an arch can't fit on the platform. So it looks like one of my arches didn't fit on the platform and it deselected it for me. So I'm going to show you on the list here. So what you'll want to do is just mark it. If you have them named by case numbers, I've taken away all the patient names that I had. So I just named them what type of arch they are. So you can just delete that and put that onto your next stack. We have some really cool new features coming eventually that'll help you plan your next plates, but for now, you'll just take that out, move the pan aside, or plan that for your next case. You can hit your delete button, or you can right-click and delete it. Okay, so you can see that I have all different types of arches, very wide arches, very tall arches, and I've almost maxed out my Z. If you need to add more to it, let's say that you didn't get in all of your arches, just hit Control Z, bring in some more arches, and then redo your stack arches. Now, the cool thing is you don't have to actually place bars anymore because we've attached them to the arches below. And we have these nice little snap-off features. So I'm going to show you this live, but it's kind of hard to see detail in my live video or my live feed. So I want to show you this up close here. And you're going to see these lingual supports. I'm going to pull those off live. But we have these little easy break off. So after you finish cleaning them, you can either post-cure them and post-process them all in stacks or separate. And when you go to do your thermal forming or whatever you're going to do with that arch, you just snap them right apart. Okay. So now we're going to hit Add to Queue. And we can name it whatever we'd like to name it. Are there any questions about that process?
Yeah, you had mentioned you took off the patient names. Is there a certain way that you label all of them since you have so many so you can identify them afterwards?
Most software will put a little number for the series on the model itself. So even though the file names are getting renamed and put into a stack, your arches will all be identifiable by visual.
Okay, perfect.
So
Thank you.
it won't remove any labeling on the actual arch itself, just on the file name, that's all.
Okay.
Okay, so I am going to now go over to the printers. So I'm going to start my camera. Everybody's favorite part. Hi, everybody. Okay, can you see my screen okay, Holly?
Yep, looks great.
Okay, cool. So here's what I have. I have my little setup, and if you guys have joined me before, you know I'm working in my home office. So it's not set up completely like a lab, but I want to show you a couple of little things that I do just for helpful things, and I did it in the lab as well. So what we have here, I have two Nextdent printers, and I have a little cart, and I have them all labeled with all of my different materials that I have. So I have 4 different materials and resin trays. And every day when I have CNB MFH, which if you closed your lab, you probably cleaned out your resin trays. But every day you want to stir your CNB MFH if you're not using it. That's the only material you need to stir every day or every couple days. So it's easy to identify. And I can just open up the lid. I have them in my garages. And I can just use my stir and I stir. So that's just a little tidbit of what you can do. This little cart was only like $20 or $15 at Walmart, I think. So I am also going to clean the lip of my resin tray, where my resin tray goes in my printer. And when I change out materials, I always make sure I do that. You want to make sure that your printer stays clean. There's not much maintenance to do on the printers at all. There's no calibration, but you want to keep it clean. If you get anything on this lip right here, this is where your tension is on that membrane. And so you want to take really good care of that thing so it lasts you quite some time. So I use this little spray bottle of alcohol, and I put a little bit of it on a white ball, and then I clean up this lip around. And by the way, if something happened and you dropped something on it, like your resin or your build platform, and you caused a chip in it or something like that, it's not ruined. Give us a call. We'll give you instructions on what type of sandpaper to use to get that nice and smooth again. There's not many moving parts, right? You have your arms. You want to make sure there's no resin on there. And you have your the elevator arms that come up and down, and that's really all that is moving. You do have these little tension arms, so you can wipe that down if you've got resin on them. You can make sure that you have no dust on your resin tray, catch tray, make sure that's always installed. But other than that, that pretty much is all the maintenance you have to do. There's no calibration, which is awesome. No more years of my life wasted on that. So what I'm going to do is I'm going to get my model material out, and I'm going to put it into, oh, this is not the right material. That's why you label your drawers. Okay. Now I'm going to put it into my printer. And this is how easy it is to change out material. There's nothing else you have to do. No purging, no cleaning. You just put that resin tray in there and make sure it's right where it's supposed to be. It only fits in one way. You're going to put your tension arms down. There's a little click that happens. And then you can stir your resin. And when you stir, you're not going to scrape or anything like that. I don't ever have my comb up like this. Use the comb that we sent you, and you'll be just fine. It's nice and smooth. There's no rough edges on it. And just go sideways like this and give it a stir. No pressure. There's no reason to put any pressure on there. But you'll be able to see that your resin needs a little mixing if it's been sitting for an hour. Now we're doing a stack, so what we need to do is we need to fill up this tray. Go all the way to the max line. When you do a stack, just make sure you have plenty of material in there. you want to make sure that if you're maxing out that Z, it's around 300 grams of material that it uses, maybe a little less. But I always like to have at least 100 grams more, so I know there's plenty of flow. We don't have a pause right now, so if you open the door, you're losing whatever hasn't printed yet. Okay, so I've got my mixer mixing, and I have 2 bottles on here. I'm going to go ahead and pour all the way up to the max line. Each line is 100 grams. And when you pour, then just do a little twist there, and that'll get the rest of that resin from coming down your bottle. You want to keep that clean because when you put it on the mixer, it's mixing around. You don't want to mess up your barcodes with resin because you were messy. Now, if you're adding new resin to older resin or resin in your tray, make sure you give it another mix. We have a stirring and mixing chart, and I'll show you that too. Okay, so give it a mix and make sure that's all mixed up. If you're doing biocompatible, you don't want to mix lot numbers. So make sure that if you're adding or topping off, that you check your lot numbers. That's just right on the side of the bottle, right by the barcode. Okay. All right, so let's install the build platform, and there's no screws or bolts or anything like that. You just put it on, it's all magnetic, very easy to install. One-handed is great. We're going to hit start job, okay? And we'll scan our bottle, scan the back barcode. The front is now non-existent, it goes for manufacturing, so it has nothing to do with the material for you. So use your back barcode. And a slight angle is fine. There's nothing real special to it. Just take it and a slight angle and it'll find it. It'll tell you how much is left in the bottle, what the lot number is, what the expiration number is, or date, and it'll tell you to confirm a few things. So you're going to confirm that your print platform is installed and it's clean, that your resin tray is full, and that your resin has been stirred. So just check those boxes and start your job, and that's all there is to starting the printer. Now I'm going to remove a build that's in my other printer, and this build I'm going to show you after I post-process my models, but this is kind of a sneak preview. So I use a cookie sheet. It has layers of foil on it. I don't want to have to clean this cookie sheet constantly, so what I do is on Monday or Friday night, I put like 5 new layers on there or more. And then every day or every time this gets really dirty, I can just take off a layer, throw it away, and I have a new clean sheet. Okay. And by the way, it is okay if you leave your models to sit overnight. You don't have to worry about the sagging or anything like that. We've already done all that testing. Everything's fine. You can leave them in there as long as you want. The only material that I really always clean right away is my MFH, because the bleach or the N1 seems to harden up a little bit. You can tell that it's curing the longer it sits, so it's a little bit easier to clean off those supports off of important areas like your occlusal areas or the undersurface for your denture arches. So I like to clean those right away. But other than that, everything else wipes off just perfectly fine. All the screws do, or all the supports do. So sneak preview. Don't tell anyone I showed you this. So you might have seen this at the trade show. We showed this at Lab Day. This is coming soon. And I'm going to show you how this actually, how these supports peel off and stuff like that. But it's really, really cool stuff. I actually have your models here as well. And I'm going to take you over to my cleaning station now and show you how to post-process these. Okay, so here's what I have. I have my stirring, curing, and mixing chart here, and it's laminated. This way I can always see how long things need to mix, stir, and cure, okay? And I can just wipe that off. You can just get that right on the user guide. You just go to a print view and be able to print it out and laminate it if you want, or just keep reprinting it every time it gets dirty. This is what else my cleaning station has. So I always have a stack of white balls. I really like them. They're very thick. They don't have a lot of lint in them. I have a Tupperware container that I got from, you know, wherever, Walmart or something, and it holds the build stand, the build platform stand really well. Perfect amount, and I recycle all my alcohol basically into here. So I've got 3 different levels of alcohol that I have, and it always ends up in here. This is the very last hurrah for that alcohol. You're always going to use 91% IPA, and I have my build platform area where they're drying. I have my stacks here, and this is the single level stack I showed you. So what you're going to do now is we're going to start with this guy, and you can see that those lingual supports here, they just peel right off. So you can just take off all of your arches. Okay, you can see that little stand I was telling you about. So if this was the full arch, the full stack, they would just sit real nice on your in your cure oven. So basically, you're just going to pull these guys off. Okay. And this was a really really short arch, so I was able to fit 10 on there, which is awesome. It depends really how conservative you want to be with your material. So then the next thing that I do is I put this into my build area that I just showed you, that build platform holder in here, and I'll come back to that. I'm going to go ahead and use this dirty IPA that I have. And the thing about when I say dirty is if you're using white models or bleach CNVMFH, if you use dirty IPA, it's okay, but you don't want to use IPA that you've had different shades of materials in, okay? Because it will absorb some of that coloration. And so when you have white parts, you want to keep them as white as possible. Now, if you don't care, fine. But if I was doing like Nextdent cast, that's more of a purple shade. You don't want it to absorb into your white model or your white tooth colors. So again, just peel off those lingual supports. Okay. And it's, I mean, they come off with literally no scarring. It's just such a fine tip that is holding those stable, those incisal edges and the mesial and distal edges sometimes curve a little bit. And so we wanted to make sure that there was maximum accuracy all the way across the board. Okay, so again, I'm just gonna do that and put this into your ultrasonic for 3 minutes, okay? So I'm not gonna pain you with that sound of the ultrasonic, but I always cover my stuff with a glove and put it in. So 3 minutes. You don't want it to stay in any longer because it'll start being eaten away. Maybe if you were like not setting a timer, you walked away for 20 minutes, you came back and you said, uh-oh, you might have weaker models or the surface may not be as hard as you would like it to be because you've left it in alcohol. So after you're done with that, you're going to put it into your clean alcohol for 2 minutes. So you always want to do a clean bath, okay? And what I do is I put all of my arches in. I actually like to take my arches out and put them in the opposite direction. And you'll also see that with your full stacked arches. So I don't actually have a big enough ultrasonic because I'm not at the lab. But if you were at the lab and you could clean the whole stack at the same time, you would break off the stack and you could put them in the larger tub, one direction for 3 minutes, all of your stacks. Okay, so we put them all like this, maybe in our ultrasonic. And then on your clean bath, you'd flip them over and put them in the ultrasonic the opposite direction. Okay, so all of your stacks like that. Now, make sure that you get all those lingual supports off before you do your post-cure because you don't want to have any scarring at all. And you could also, if you were wanting to use beakers, you could also put them in like this as well. So you could stand them up, okay, in your beakers. So that's what we'll do with this. And so for 3 minutes and then for 2 minutes. So peel off your lingual supports, put them all in. And look, guys, if you have a small ultrasonic and you don't have room to even put them in a full stack, you can just break apart the stacks right now and put them all in like you saw me do with the single level, okay? So this one is 40 models in the stack. And so you can see that really doesn't take much time to pull these little lingual supports off of there. Okay. So again, you would just fill that with alcohol. I always would, on my second bath, I would change the orientation of them, fill that, do my 2 minutes, okay? Then, very important to remember is you want to make sure that all of your models dry. If you're having any breaking parts at all, no matter what kind of material you're using, if you are curing stuff with IPA, or if you're cleaning things with IPA, and you put something into a warm oven or heat it up, it will explode in the part wheel. So you'll get like microfractures or cracking. So it's really important that after you're done cleaning your parts, that you let them dry. Use your air hose. I don't have a compressed air here with me because this is my home office. But so I have to let mine sit for a half an hour. But if you had air, you could just dry them with your air hose, okay? And when I dry my parts, I like to set them up. Can you see that? I like to set them up against the oven. So you can see I have all different kinds of parts that I'm printing today. But everything is drying and it's all setting up upright, okay? So after you've air hosed it and dried it, turn on your oven. You can see your cure oven chart. And for models, it's 10 minutes. If you, and I have some photos for you on the remainder of the PowerPoint to show you the different scenarios and the ways that you can set them up in your oven. But there's little feet on the bottom of the stack. You can set them right in your oven, standing up, and you can fit several builds in there. Okay, it's a really big build area or a cure oven area. In fact, I'll show you the platform in here. So you can see how large this platform is, and you can fit multiple builds on your platform. You just want to make sure that they're spread out slightly, so this way the light can get in between all of them. Now, if you're doing single larges, a single row, and you only have 6, just place them normal on the build platform laying out. Is there any question about the post-processing that I've shown you, or any tips or tricks you'd like to know more about? Holly, any questions?
I don't have anything as of right now.
Okay. Now, when you go to clean your build platform, within just a couple of minutes, right when I'm waiting for my parts to be in the ultrasonic, I just use my punch tool, and I'll go through and I'll do my punch, okay? And then once you go through and do your punch, then and this punch tool came in your accessory kit, then you're gonna use this other tool that came in your accessory kit, this scraper, okay? And you'll just get the remaining parts off of there. So there might be a couple of things that are waiting or that you didn't get punched, depending on how thorough you were with it. And you're also you have a paintbrush that came. So that's why I like to have it in this little bath. I just brush off my part or my build platform. And I always rub my glove on the bottom. So I want to make sure that I don't have any residue at all, any cured area, because I don't want it to come down and touch the membrane over and over again. Then what it would do is it may wear like a weaker spot in that membrane. So I always ask, make sure that you go through and feel that and make sure it's not, doesn't have any more parts on it, any more cured parts. And then I put a layer of white ball on my other build platforms, and I just set it right there. And it'll be dry and ready to go for the next time. And finally, something that we're still working on is the next thing that we're going to be working on is denture stacking. So you all saw this at lab day if you came and visited, but if not, it's really cool. You can just peel these off and it leaves no scarring at all. Okay, just a little sneak preview. So now I'm going to go ahead and sum up this presentation with a few tips about how big the arches should be, things that we're still developing with it, and then some of the features that we've added recently that you may not know about in 3D Sprint. So I'm just going to pause my camera real quick. and bring you back to the PowerPoint. Okay. Oh, so we don't need my camera view. All right, so the post-processing is exactly what I showed you. Here's a couple of examples here. So you're just going to remove the stacks. And by the way, on the PowerPoint, we will, I'll be giving it to Holly, and she will disperse it to you. Nextdent and 3D Systems have made a great video on how to use this whole process as well. So I'm going to put a link to that. So the next thing you're going to do, and here's an example. I have a smaller ultrasonic, so you saw me use a beaker or break the stacks apart. But if you have a larger one, you can use a bucket here. And you will sonicate it for 3 minutes, flip it over, flip all the arches over, put them in their clean bath, sonicate for 2 minutes. And then you'll just dry it with compressed air, and you're going to peel off those lingual supports either before or after you clean the parts. Okay, I like to peel them off right away, right when I remove them from the stacks or from the build platform. And then you'll cure it for 10 minutes. And you can see that some of these are standing on their feet. There's another option. You can lay them down flat, and you can stack the little insert that goes into your cure oven. Okay, a couple of facts are it accepts both solid and hollow models. The software will maintain your labeling and your attachments. Software automatically places the arch in the orientation it'll fit. So if it's super wide and won't fit across the plate, it will just orient them the opposite direction, as you saw. And the lingual supports may be removed prior to post-cure, but don't modify them during nesting. They won't leave scarring, so you don't have to worry about it, even though it seems a bit intimidating. And currently under evaluation, so when you guys start using it, you just want to look out for a couple of things that we are still working on, and that's full palette models, in-shaped models that are missing a part of the arch, or something that's missing teeth like this, and then attachments for machining. So for special workflows, you'll just need to work directly with us, and we will talk about development for that. Now, you want to fit the max number of arches on your build platform. There's certain standards that you can work with your technicians and say, hey, keep these around this tall if you can. These, you'll start being able to eyeball them, really. I mean, a lot of the beta testers now so far they can tell exactly how many arches are going to fit. They'll bring in all a certain number of sizes. You can see it in the pan if you're looking at impressions. It really depends, but you get really good at being able to try to cram as many as possible onto that plate. And for 18 to 26, anything over 15 millimeters tall, it'll probably be on the lower end of the models, the lower number. Anything over 60 millimeters wide or 60 millimeters tall may decrease the number of arches that you can fit into your stack. And what's next? I showed you a little sneak preview. There's all kinds of things that we can do. We do always consider carefully everyone's requests, so please speak freely, ask for certain things that would be useful for you. That's what we do, right? We're all dental techs here that are working on our team. We want to make life easier for dental technicians, easier for managers, and help people see their ROI. So some of the newest updates, if you make surgical guides, you have the printer, you may have not noticed this unless you actually read the changelog. And that is when you go to do your smart support, you can choose 2 different supports now, general or general fine tip. If you choose fine tip, it makes much smaller supports, so you're able to actually add more or not worry about them being on that flat surface where the sleeve will fit. We actually added a new build style for Nextdent Cast. You may have saw it, but we're worried about using it. We actually are able to maintain the same accuracy, but increase the speed. So we went to 50 micron slicing. We added it in addition to the 30. And we did tons of trials and testing, and we're able to achieve that 30 micron accuracy with the 50 micron slicing. So you won't see a difference in the quality. And we also added premium build style. So if you'll see premium now, whenever you choose model, that'll be one of your selections. And you'll see that it looks like a poured model. It looks like plaster. Beautiful build style. Takes longer, so don't use it unless you really, really want to, or you're going to be polishing your model. But it's not necessary to use constantly. just for aesthetics only. And we also updated late last year, for CNDMFH, we now support shell temps. It was originally configured for denture arches, and now we've added that additional indication. And we also got our clearance for Denture 3D Plus, so if you want to try it out, it's now available in the US and Canada. And support bars with one easy step that's actually outdated, that is coming with your stacked build around the end of the month. And this is what the support bar function looks like. So now instead of generating a geometry and making a cylinder, you'll just go in, you'll grab your file. You'll want to use it for like a lower denture or an orthodontic model if you're not using the stacked feature. So what you're going to do is get a decent view, hit create bars, click on each side toward the distal and hit apply. And what's cool is you can actually connect bars to bars. So if you wanted to make a variety of different bars or sprue or something like that, you can change the dimensions and use it for whatever you would rather use this for instead of your CAD. Okay, and then we introduce new build styles regularly. We don't always wait for a new sprint update. So if you ever see a new build style come out, it was announced, you can just go to our website, and then what you'll do is you'll just hit your little gear here, your settings, go to about, and you'll just hit a database patch, you'll hit import, and you'll be able to bring in that new build style. So it's the little gears or the settings, about, and then import. And now I think you guys are all Nextdent owners, but I always brought this in because these are the US MSRPs, because the first question is, well, how much does it cost? So I wanted to give you an idea. Obviously, people do package pricing and things like that. This is what the printer looks like with the pedestal and without the pedestal. It can sit on a countertop or a desktop. The pedestal is totally optional. And the resin tray actually comes with the printer. But if you have like several different shades you want to do, it's much easier to just have another resin tray. So the things we've covered today are the nesting software, the long-lasting tray that can be used for every one of your materials. I do have a video on how to clean that resin tray. You just go to our website. I'll show you the website that you can go to look at the user manual. And we have videos on just about everything, from nesting to cleaning your tray, maintaining your printer, your easy to remove supports. And in my general session, you'll see how long it takes for everything to print and how accurate it all is. So come stay tuned for that, or watch the previous one that we've done. We also cover in the general session is the regulatory compliant workflow, what all it entails, how it's integrated with other software. And as we talked about today, it's all made by the same company, and we have a strong focus on support and education. We work through great resellers, just like aesthetic professionals. And also, we're now introducing capacity that grows with your needs. So stay tuned, because stacking is, we're just at the cusp of it right now. And we're going to have many more features that are coming, being able to max out your printer's capabilities and put as much as we can in one build for you, all automated. So feel free to check out our academy. We're going to have a lot of webinars coming from Nextdent and 3D Systems while we're all sitting at home, or while everyone is trying to take up that time to learn. And if you want to learn more about it, I think that I will have that in the PowerPoint where the exact academy is. So if you just Google Nextdent 5100 user guide, it'll pop right up. And in the last 18 months, we've had 1 million dental parts made on over 2,000 Nextdent 5100s. So thank you for joining me very much, guys. I really appreciate it. I want to take this time to answer any questions. I kind of rambled on and on again like I did last time, but I want to open the floor if you guys have questions, or feel free if you're shy to email me or email Holly, and I will definitely make sure that this presentation goes out along with some extra videos that we have for all this information too. So, is there any questions?
Thank you so much, Adrian. I just have one question. How about stacking crown and bridge full arches?
Yes, so I wouldn't stack anything with a removable die yet. We're working on those. It's coming. This one was specifically geared toward cases that don't have removable dies, so they're geared toward orthodontic arches. Since there's so many arches that go into a series right now.
Okay, awesome. Thank you so much. And I'll send
Okay.
out an email with the video and the PDF to everybody too.
Thanks,
So,
guys. Have a great afternoon and stay safe.
thanks, Adrian.
Thanks.